I'd like to introduce the next chapter of the book by first using an example from everyday life. In statistics, we have basically two methods of statistical inference. One is what we just completed, and it's the idea of a confidence interval. I find an interval, and I'm, say, 95% confident that the true parameter, the true value of the parameter, is in this interval. I'm pretty sure the right answer is in here somewhere, is essentially what we say with a confidence interval. The other idea is the concept of a significance test, and that's what we go into in the next section of the book. A significance test takes some claim or some initial belief, weighs the evidence against that claim, and then makes a determination about whether you should continue to believe the original thought or if you should change your mind and believe something else. So how does that work? And I'll kind of use some statistical language in the course of explaining it with something you already know. In the United States, if you're arrested and put on trial, we have a presumption of innocence, which means the jury should assume that you're not guilty until the prosecutor presents enough evidence that persuades you of the person's guilt. And so the way that would be written in statistics is like this. HO, which is my null hypothesis, it's the hypothesis original, just like the initial velocity or something that you might see in physics. HO is the original belief. We originally believe the suspect is not guilty. The alternative hypothesis is what you'll have to believe if you quit believing this. And in this case, we think the suspect is guilty. Now, in statistics, when we set a problem up like this, you are always acting as the prosecutor, looking for evidence against HO. You're always the prosecuting attorney. So we're going to collect some evidence and see how strong that evidence is against this null hypothesis. The jury will weigh the strength of that evidence against HO, and they find in statistics what we would call a p-value. A p-value is essentially the likelihood that I would get evidence like I got if HO is true. So in other words, if you really are not guilty, how likely is it that you would be found walking around in a very similar set of clothes to what the eyewitness saw at the scene of the crime, that you would have an equivalent amount of money in your pocket from what was taken, say, from the convenience store, that you're hanging around with guys who were captured on film and known to be other suspects or other perpetrators of the act, and still be not guilty? How likely is it that all that would happen and you're not guilty? It's not very likely at all. So I'm going to reject the idea that you're not guilty, and I think you are in fact guilty. In that case, we have a very small p-value. It's really unlikely that all that stuff would be true and HO is true. So I'm going to end up rejecting HO with a small p-value. On the other hand, if my p-value is large, it means it's quite probable that this could happen, even if HO is happening. There's not much evidence against that. So again, if I have a small p-value, I reject HO and start believing HA. If I have a large p-value, I'll fail to reject HO in favor of HA. Now the p-value, again, this Y, is always the amount of evidence against HO. You're the prosecuting attorney. You're never trying to find evidence against HA. You're finding evidence against HO, and then you're determining whether that evidence is a lot of evidence or a little evidence. If it's a lot of evidence, I end up with a very small p-value, and I'll reject HO. If it's a little bit of evidence, I end up with a large p-value, and I'll fail to reject HO. That's the general idea of a test of significance. And now we can apply this concept to something that looks a little bit more mathematical.